In this video, we're going to be looking at standard form and what standard form means and the common things you have to do with standard form. So, standard form looks like this. It will be a number that is between 1 and 10, but we can't actually include 10. So, like 9.999. You could think of it like this if you wanted, but 1 to 10, not including 10, is the easiest way. And then we have times 10 to the power of some number in there. This can be positive or negative. And if it's positive, then we're multiplying by 10 squared, 10 cubed, like 100, 1,000, 10,000. We're making the number much bigger. If it's a minus power, a negative power, then we're making the number smaller because we'll be dividing by 10, 100, or 1,000. Okay, so if you're talking about distances of planets from the sun, you will have a positive power in here. If you're talking about the size of a nucleus in an atom, you would have a minus in here. Okay, so let's have a look at a couple of examples. Something like 3 times 10 to the power of 4. What we do is we write down the number 3 and we look at where is the decimal point at the moment. Now it's kind of hidden here, all right? But that is where the decimal point is currently. And when we multiply by a positive power of 10, we're going to move the decimal point to the right. In this case, 4 spaces. So that decimal point is kind of going 1, 2, 3, 4, ending up there. And any arches that are having nothing underneath, we're going to add a 0 in here. Okay. So a lot of students will say, oh, I could just add 4 zeros on the end, which is true if you have a whole number here. As soon as you have a decimal, that rule goes out the window. So try to think of it in terms of moving the decimal point. As an example, 3.25 times 10 to the power of 3. If I write that number 3.25 and I move the decimal point 1, 2, 3, so that ends up here, and we put a 0 underneath. You can see we only actually added 1 0 in this case because we have the 0.2 and the 0.5 to kind of jump over. So I would say using this idea of moving the decimal point by this number of places is the most straightforward way to do it. And if it's a minus, we just go the other way. We just go to the left. So if we had 3.5 times 10 to the minus 4, we write 3.5 and then we're going to move to the left. So 1, 2, 3, 4. The decimal point is now here. Put zeros under these arches and we have the number 0.00035. Okay, now this is nothing to do with standard form really, but in tradition we kind of put a 0 here. 0 point, that's not really anything to do with the standard form. That's just what happens if the decimals are small. We have to put that 0 on the front. Okay, so 0.00035. This process of turning standard form into a number, you will often be asked to create or give the value. Okay, so we're finding the value of this number and we're doing this process. Now, this would probably only be done in the non-calculator paper because with the calculator we can just put these numbers on, like 3 times 10 to the power of 4. The calculator will do that for us. Okay, the problem we have is with very, very large numbers and very small numbers, the calculator will keep it in standard form because it doesn't have enough digits. Okay, so sometimes you do need to be able to do this process if the calculator doesn't cope with it, or if you're in a non-calculator paper, you would definitely need to be able to do this. So you kind of have to learn it. Now, in the non-calculator paper also, we might be asked to do some calculations with standard form, something like this, 3 times 10 to the power of 4 times 4 times 10 to the power of 2. Okay, you could turn this into 3 and then 1, 2, 3, 4 and then multiply by 4 times 10 squared. 10 squared is 100, so 400. And you could do your long multiplication with this. But there is an easier way, and that is prone to error. We can just multiply the two numbers. 3 times 4 is 12. And then we can multiply the powers, which would look something like this. And from our indices work, when we multiply, we just add the powers. So we've got 12 times 10 to the power of 6. Okay, we're nearly finished, but we've kind of broken the first rule here. That number has to be between 1 and 10. So 12 has to be changed into 1.2. Now, this is a bit confusing at first, but you can learn the pattern, or you might be able to just write this out fully and then confirm this to yourself. But when you divide this by 10 and make it 10 times smaller, we have to make the power 10 times bigger, and that will increase this by 1. Okay, so let's just have a look at 12 and then 10 to the power of 6. 1, 2, 3, 4, 5, 6. 12 million. Okay, you don't have to worry about the commas, just makes it easier to read. There's the decimal point here. We have to put it somewhere to make a number between 1 and 10. There. 1.2. And then how many places did this decimal point move? 1, 2, 3, 4, 5, 6, 7. Okay, so that's how we go from a normal number back to standard form. We place the decimal point where it should go to make a number between 1 and 10. Like there would make 120. That's no good. 12, 1.2. Yes, that's between 1 and 10. Okay, so that's the main thing you have to do with standard form. If this was a divide, I don't think they'd give you that, but if it was a divide, we would do the opposite. 3 divided by 4, and we would subtract the powers because that would be a division.